Hello and welcome to this presentation for IASS 2020-21. My name is Michael O'Shea. I'm a lecturer in structural engineering in Limerick Institute of Technology in Ireland. And I also have about 20 years industry experience, most of that as a structural engineer. My paper is entitled An Introduction to Spatial Structures for the Practicing Structural Engineer with case study. The premise for the paper is my perception that a lot of the structural engineering community are not very familiar with spatial structures, and that this limits the application of spatial structures and also limits structural engineers in terms of the palette of solutions that they can offer on projects. And the paper attempts to provide a concise introductory guide to these structures for practicing structural engineers, to allow them to develop their knowledge and maybe act as a seed to developing their knowledge of spatial structures. So the paper, starts by talking about what spatial structures are, referring to their, three-dimensional nature and behavior. Looks at categorization of spatial structures, and includes an infographic that I've prepared to show the various types of spatial structures, commonly employed in the different categories. Examples then are provided for most of those different types of spatial structures in the infographic. And the paper discusses some of the differences between conventional structures and spatial structures, such as connections, which tend to be more complex for spatial structures than conventional structures. And the paper, talks about different systems then that have been developed to deal with that aspect of spatial structures, and looks in a little bit more detail then at the Miro-KK ball joint system, one of the most popular systems for joining members in lattice spatial structures. A case study is then presented, as an application of some of the introductory material presented in the paper, to show the type of real life project where spatial structures can be applied. The case study relates to the roof of a sports building. This is a project that I was involved in, leading a team who carried out an independent design check on the structure, including the long span roof. On the actual project, a conventional solution was adopted for the long span roof in the form of a post and truss system, as shown in the two lower illustrations on the slide. So the case study goes on to look at different spatial structure solutions that might have been adopted instead of the conventional solution, and then it takes one of these i.e. a flat grid, and goes into more detail in terms of analysing and designing a grid for the roof structure. The paper discusses various options for grids, and then selects a double layer grid with a square on diagonal form for the roof. Gives some reasons for that selection, and then goes on to establish the geometry of the grid in terms of grid depth and the plan dimensions of the grid module. The case study then goes through analysis and design of the double layer grid solution, including preliminary member sizing and several iterations of analysis and design to refine the design, with finite element modeling and analysis done using LARSA 4D software, and some of the results of that presented. In conclusion, then the case study compares the weight of steel in the roof for the conventional design to that for the spatial structure solution looked at, and highlights a saving of approximately 20% in steel weight, which is obviously very significant. These are my contact details if anyone wants to contact me regarding the paper or presentation.